All right. Well, good evening, everybody. I'm Roy Bourgeois, and welcome to what is actually the third presentation of the Greater Boston Soaring Club Cross Country Seminar. And this is the basic version. This program began actually 10 years ago when Rick Roelke and I did it for the first time, as I recall, at WPI. And then we did it again about 2 or 3 years later. And now here we are 10 years from when we did it first. I guess the first thing that I want to do is to introduce Rick, and then Rick will introduce me. But my co-host and presenter is Rick Roelke, also known as Romeo. And Rick's been flying gliders since 1973. He had a long experience in both piloting and designing hang gliders, and he has about 800 hours in hang gliders. Today he has about 2,500 hours in soaring. He holds the triple diamond badge, which is actually the first triple diamond badge done only in New England, at least in the last 40 years. He also has the World Soaring Award attached to his diamond badge, which is done for flying cross-country 40,000 kilometers, which is the circumference of the Earth. You also know Rick as sort of the spark plug organizer and guru of Mount Washington wave camps. And in addition to that, Rick is also a current member of the Soaring Society Badge and Records Committee. He's a senior observer, and he is also newly appointed as a director at large of the Soaring Society of America. So really happy and pleased to have Rick with me. So Rick, I'm going to hand the baton over to you now, and you.
All right.
Well, let me know when you need me.
Yeah, will do. Again, let me introduce Roy, who so graciously introduced me. Roy's been flying in New England, well, it's probably not the right thing to do forever, and has logged, as you see, over 4,000 hours of soaring, 25,000 kilometers of cross-country gliding. That's a lot of times around the equator. He holds a diamond badge, 750K diploma, and 3 United States speed records. Roy called me from South Africa that he was about to do these things, and a pretty remarkable achievement to have done. Those were all in the same year, Roy?
Well, yes, 2 were done in December and 1 in January.
Yeah.
The same winter.
Same trip. And so he set his sights on them and pulled them off, including the rather arduous documentation tasks. He is our chief pilot at GBSC, and he's competed in 10 US and Canadian nationals, and also in the Pan American Championships, which is a FAI contest. He flies his ASG 29, which everyone has heard, Romeo Oscar Yankee. He also has 133, or I should say half of 133 in South Africa. He's served as the president of GBSC. Were you president of MITSA as well?
Yes, I was.
Yeah.
Way back in the dark ages.
Yeah. So, and as a fantastic cross-country mentor, has taught me an enormous amount over time, and is about to teach you some. So let's move on to, this is our agenda. The introductions are over with. We're going to have a little brief thing about the virtual meeting rules, and this recurring theme we have, which is relax. It's not as scary as it seems. I'll present steps from solo to cross country, and follow that with how to fly local and cover ground, which is really an interesting topic. And then Roy will give basic cross-country flying tips. We'll move on to how to use a flight computer. And then Roy will have a guided tour of straight out to Danielson as a possible silver task. We think that is going to be tonight's presentation, but we're not exactly sure where we're going to end this. Then silver badge tasks. So as you're out trying to do your silver, this is how you're going to document it and get it done. And then Roy has another guided tour straight out to Taunton. I'll do a brief weather overview. It was very interesting looking at this presentation that we had done 10 years ago, how much has changed since then, and really how much easier it's gotten for weather analysis. And then perhaps the highlight, I think, of the presentation is choosing fields. It's a great guided tour, what fields look like from the air and the ground. And then we'll have a review, and any questions that you have, we will try to answer. And we'll do that also at the end of the first half of the presentation. So these are the rules. I have been turning off mics and videos from Central, just so that it's not a distraction. And then ask questions via chat. You can send it to all. If I'm speaking, Roy will field those questions, and vice versa. And at the end of each section, if we've got appropriate questions, we'll answer them. And if you have a technical issue, you can try by chat, but otherwise we don't really have any good recovery. All right, Roy, you want to take this one?
Sure. Most of what we wind up talking about with new cross-country pilots is simply fear of flying cross-country. The emotional impact of cutting off the apron strings and leaving, which sometimes can be more severe for people who have an airplane background than a glider-only background. And one of the things that I find helpful to remind everybody is that you already, if you've flown 2 or 3 or even 4 hours over your home airport, you already are a silver distance pilot. Let's just think about it for a minute. If you flew locally over Sterling Airport for 3 hours in a 15-mile-an-hour wind at 3,000 feet, the air mass that you're finishing in was 45 miles away when you started the flight. The air mass is moving, you're standing still. It's a fairly simple thing then to just fly 45 miles through the air mass. And I find most of what I try to do with people at the beginning is just get you to calm down and relax and enjoy the fun, the thrill, and the magic of flying cross country. It's one of the most interesting and fascinating things in the world, and so much of it is just getting past that initial idea that, well, I'm going to fly away from a place without a motor. We're going to try and teach you to do fine, but for those of us who do it all the time, we are just as relaxed 50 miles or 100 miles or 150 miles away from Sterling or as we are flying locally. It's the same sky, it's the same cloud, it's the same technique. So you're already there. If you can keep the glider in the air for 3 or 4 hours, you're already ready to fly cross country. We're just going to help you make it a little easier. Rick?
All right. So how do I get there from here? You know, you're a student pilot and you want to know how to get there. You start with your license. You know, once you've got your license, the training, so to speak, is, you know, structured training is over. But one of the things that I think is universally true amongst soaring pilots is that we enjoy this because we are constantly learning. And, you know, you study hard to get that ticket, but that's really when it starts. You start to learn about the atmosphere, you start to learn about your own abilities, you improve them. So start there. And this is important. You need to be confident in your thermaling ability. So how could you do that before you go cross country? You can practice some lower saves near the airport. Don't get dramatic, but you know, it's an opportunity to practice some higher bank turns. In my experience with new pilots, there's a aversion to really banking tightly. And so you can practice that with doing 15-second 360s. Head on course, start to do a 360 and time it when you come out back on heading. How long did it take you? 15-second 360s are pretty steep. You want to do it high, you don't want to be doing it at the ground, but just to get more comfortable with the idea of banking steeper. And you can get off toe lower. One of the things we changed at GBSC was to give a policy of per 100 feet so that you have a financial incentive to get off low. And it'll get you more comfortable being low. I was at a cross-country seminar that Doug Jacobs put on, and he, as a way of calming himself down, you think Doug's a pretty calm guy, but you start to get low, and then when he gets down to 2,000 feet, he says, oh, this is where I start every contest. So I've got no problem finding a thermal. Set goals. This is important for your development. You can set goals of badges. That's really what the badge program is for, is to be a defined set of goals. But personal goals, work on your short field landing, duration, flying to particular turn points. When I started flying gliders, I went to visit all my haunts as a hang glider pilot. So I'd want to go to Ascutney, or I'd want to go to Kearsarge. And those were goals that I used along the way. And land at other airports. Soaring is kind of strange in aviation training that we end up at the same airport all the time. It's absolutely standard to go off in a power plane and land at other airports. So to do that, I strongly recommend taking advantage of encampments. That'll get you takeoff and landings at other airports, Franconia, Gorham, and travel. You know, take advantage while you're out or going to Florida or something like that. When we do get to do that again, gives you a good opportunity for learning other airports. When you're practicing your thermaling, the other thing to practice is cruising. So glide to a known distance, use your thermals along the way, but don't turn. There is a common error, so to speak, amongst beginning cross-country pilots to take every thermal you run across. And I just want to say right from the get-go, that's not a terribly bad thing to have to do. It will slow you down, but getting high, staying high is a really good thing for early pilots. Over time, you'll work against this. You'll be learning how to fly through a thermal that, you know, wasn't very good. And so you've got that habit. You eventually need to break it. You don't necessarily need to break it to get 50-kilometer flight in. And pay attention to what the glider's telling you. This defines something called the stritic wiggle. If you're cruising along in straight flight and the left wing starts to come up a little bit, veer to the left a little bit, and that may keep you in better air. Part of making an efficient glide is trying to stay in good air. And Condor is great. You can practice, and a lot of people are flying Condor now that, you know, we're having difficulty getting in the air. The last thing is the important one. Don't get used to having 9 lives. You know, you can try things that you might not otherwise do, but don't be emboldened by the fact that you pulled it off in Condor, because the consequences are a lot more serious when you're doing it out there. And practicing with your flight computer, doing it with Condor is a great way to do it. But in any case, whatever the flight computer is that you're using, or if you're going to use the SN10 that's in the B4, it has a simulator. You can get used to practicing that at home. Fly past Fitchburg as just the notion that it's got another opportunity. However, I flew over Fitchburg today and it is clearly closed. All the runways are X'd off, which is kind of unfortunate because it's a nice stepping stone. But, you know, if you fly over to Gardner, use Gardner as your home base until you've got a comfortable way back. And this is somewhat left over from the last one. We had put together 3 sort of mini syllabi for instructors to help you with, but I think we can do it without those syllabus. You know, find somebody that you like the way they fly and get some thermaling practice. Desi gave me a lot of thermaling practice in my early days. And again, a cross-country pilot can be happy to give you a little 2-place cruising guide. And this visiting is, again, the idea of going in a 2-place ship and going to another airport. We had talked about, haven't done officially, but talked about flying over to Gardner and getting a retrieve from Gardner. And it sort of gives you exercise in both of those, you know, landing there and what it takes to get a retrieve. So the badge path, bronze first, that establishes the sort of basic knowledge base that you need for early cross country, and then onto silver, onto gold, and onto your diamonds. We had a mentor program at GBSC. I think it's easy enough for us to restart it. We put in a new group that I think many of you are members of because we crossed it over from the old Yahoo group. But if you are not, this is a good place to go and ask questions of the group. And if you don't have somebody that you feel is acting as your mentor now and you'd like to be paired up, just let me know and I will find a happy volunteer. I think my mentor really was Charlie Ryan. I don't know that all of you know him. He's moved to Texas. But after I'd gotten my silver, I'd get a phone call and he'd be, looks like it's 300K day tomorrow. And that would hang up. It's like, oh no, now I've got to prepare and get ready. But those little nudges go a long ways. And having somebody that you can comfortably ask questions to is great. So we can get you paired up one way or another. And the most important, fly always. You know, if you're only looking for the best days, you won't learn all the skills you need. So if it's a mediocre day and you're staying local around Sterling, there's a lot of good skills you'll learn there. It's often been said that East Coast pilots make the best competition pilots because they've had practice on the weekdays. So yeah, if it's flyable, fly. All right, so now we'll talk about what it is like. This is, to me, the most important rule for budding pilots is that you are going to fly. You've all flown locally around Sterling. What Roy talked about in being able to fly through the equivalent air is almost the same as cross country. The biggest difference is that around Sterling, you've got the house thermals, the green school, the quarry, these ones that you kind of go searching for when things are not looking good. When you fly cross country, you've got to be reading the clouds and reading the ground for new lift sources. But the really important thing is that you are really just, when you get in the range of the next airport, you've committed to that airport, that's your home field. Don't leave it till you can safely leave. And you're perfectly safe because it's got a perfectly good runway. And yes, you need to be practicing and have instruction, which you're going to get some in this course, of how to land in a field. But you really don't need to do it to do cross country. So start at your home field. Don't advance until you're sure you have your next airport made. Your flight computer will help that determination. And once committed, it becomes your home field once you're past the hump. And then rinse and repeat. And you just keep doing that airport to airport. And next thing you know, you turn around and you can't see Sterling anymore. And that's an interesting feeling. This is important in red. Avoid get home-itis. You know, it's a thing that's talked about in power planes. But if, you know, there's nothing special about Sterling that means you have to get there right now. I've seen pilots who got nervous and barreled their way back to Sterling, losing a whole bunch of altitude that they didn't need to worry about because we were happily over Gardner. And so you really need to avoid that. A lot of accidents have happened because of, you know, sort of thinking it's better back there. And the happiest airport is the one that's right below you. So here's a little graphic of what this is all about. So here's our home airport. Here's our destination airport. The wind's blowing towards us. So the halfway point isn't halfway between the two airports, but it's the place that gives you the same arrival altitude at both airports. And when you do it, you're climbing, you come down to where your comfort level is in terms of getting back to this airport. So this doesn't have an altitude on it, but maybe that's 2,000 feet, maybe it's even 3,000 feet over your home field, this glide slope. So you advance till you get there. Now I got to climb, or maybe you've climbed before, keep going. But this is an example of, whoa, I'm not going to make it. I tried to push forward. There was no lift. I came back. Oh, I got a good one. Came up. Now I've got the next airport made with a comfortable margin. And that, looking at this in terms of cloud base, if the clouds are down here, you can't do it. You can't, you know, you can't get high enough to be able to make the advance. If cloud base is sort of just high enough, then you've only got a small section here that you can get to. And this is, we talk about this as sort of stepping stones. You very carefully advance until you finally have got your next airport made. And if at any time this isn't going to work out, you have a safe retreat back home. High cloud base, like today, 10,000 feet, you can advance from way back here and still have it made. So obviously higher cloud bases make this airport to airport hopping much easier, but it's all about the same rule. Get to where you're going, get here. Now this is my home airport. I'm not coming back from this altitude because I won't make it. I've still got to get up over the hump if I've got to come back this way. First one's free. We made a policy that your first nearby aero retrieve is free. So you can't go to, you know, Gorham and land out and get a free one back. But this was really put in place with the same idea that don't try to get home from Gardner when it's marginal. Land at Gardner. We'll come get you. And that's why we put that policy in place. Sterling isn't the airport around. It's not even the best airport. There's plenty of airports that are longer, bigger, nicer. And again, if you've never done it at another airport, land with an instructor or go to an encampment. Encampments are really great things. If you can't comfortably advance. You're out over Gardner, you can't get it back. Land to get your retrieve. So if you've got to land at a foreign airport, what do? You want to get on the airport frequency and announce your intentions. If you are at an airport that doesn't have gliding, which most of them don't, it's perfectly okay to talk, tell them you're a glider. I've talked to traffic when I'm trying to climb out from an airport. People have always been very gracious about, giving us time and such. You want to use the working runway. You don't want to get tricky here. If everybody's on one runway, go ahead and do it. Land on the runway. Don't assume the grass is okay unless you have some prior knowledge, because it's quite often not. And clear quickly, but don't get creative. Go ahead and land straight on the runway, come to a stop, and then get yourself off. But don't try to go wheeling off into the rough or a taxiway or whatever and take out a runway light or damage the glider. Watch out for lights. If you're in contact with the authorities, the people on the ground, then ask them what they want you to do, because sometimes people think a glider landing is like a national emergency. And so do whatever they ask you to, and generally they're there to help. But they're, I know people who've landed at Worcester have run into some, interesting experiences. Leave your radio on so you know what's happening if there's any landing traffic, and get ready for the retrieve. Don't just sit around and eat the ice cream at Jaffrey. Make sure your glider's ready to go so you're not holding up the retrieve crew. So why land off airport? If you can fly airport to airport, why do people land off field? That's the most important reason. Airport to airport, you need to retreat from time to time. And back to that diagram that we had, if you can't push forward because you've got a long and you consider unlandable terrain, because you're trying to get over that hump, then, if you have other options to land, you can safely advance. But again, at the beginning, you can pick the day that will get you airport to airport pretty comfortably. Longer tasks require more speed. You start to go for your gold or your diamond distance. You can't necessarily pull that off entirely airport to airport, except for a very, very high cloud base day. If you have more landing options, you can continue making forward progress. And that's something more about in the advanced course. And that's it for me. Back to you, Roy. Oh, so I need to stop sharing, right? All right, you've got it. I can't hear you. Do you need me to unmute you? That would be unfortunate. Let's see. Where did that go? Here we go. Sorry, Roy, the chat has consumed this place where the manage participants. There we go.
Okay, can you hear me now?
Yes.
All right, that's great, thank you. I have to set up my screen here, and am I now the host also or not?
You are not, but I don't believe you need to be, but I'm happy to.
Let's see what we need to do.
Throw it your way.
Hang on. And are you seeing?
Still seeing you.
And nothing else, right? Okay.
Yep. Are you seeing a share?
Let me just go to share screen.
That'll do it.
How's that working?
Not yet. Why don't I throw the host at you?
Yeah, why don't you do that? I think it's easier.
Okay, where did you go? One minute, seeing you here. Oh, there you go.
All right, you got it?
Yeah.
Excellent, good. All right. I just want to go back to beginning and all right. One of the questions we get asked all the time is what's the minimum thermal height for flying cross country? What's too low a cloud base to get going, and what's good enough? And every time I get asked that question, I start by asking the person a set of questions. How experienced are they? What type of glider are they flying? Are they going upwind or downwind? Are they airport hopping or doing farm landings? The higher because one of the things that you come to realize when you do this a bit is that the higher the thermals go, the more widely they're going to be spaced. The phrase that is the area from which the warm air that creates the thermal draws is called the fetch area. And there's a very distinct relationship between the size of the fetch area and the height of the thermal. So, if you go off and most experienced pilots have gone off cross country on 3,000 and 4,000 foot days. We do it in contests all the time. And it's actually kind of fun because the thermals are so closely spaced together that you bump into one about every 30 seconds. And you can do a lot of straightforward flying. But that said, what I normally recommend is a height band of at least 4,500 feet above the ground. And the reason for that when you're at the beginning is simply that it gives you time to relax. If you're flying at 3,500 feet above the ground, or even 4,000, it doesn't take long before you're below 3,000 on a normal glide, and that's when things start to get busy when you're new. So the higher you can go, the more relaxed you're going to become. And so I would think at this point, if you're a new cross-country pilot, and that's probably why you're listening to this program, that is about what your minimum should be, 4,500 feet. Now remember, in the beginning of the day, thermals start out a little bit lower for cloud base, and they normally go up over the course of a day. In New England, you can usually see thermals start about 11 o'clock in the morning, and they'll normally go to about 2,500, 3,000 feet. As the day wears on and the ground is heating higher, the thermals go higher and higher, and it's not uncommon to see a 2,000 or 3,000 foot increase in the height of the thermal as things go on. One of the first things I want to talk about in terms of cruising, and most of what we're going to talk about today is cruising, because number one, I've already assumed if you're in this course, you know how to thermal. But what will surprise you is that in the advanced cross-country course, which is coming up a couple of weeks from now, we spend a huge amount of time talking about thermaling and how to get from being able to do it to being able to do it excellently. But what we try to do here on a typical day, what we do is divide the altitude that we're going to use into bands. And what that means is that I'm trying to figure out what I'm doing here. what we do is we divide the altitude above 1,500 feet. 1,500 feet is our place where we're really getting ready to land. But they divide the altitude above 1,500 feet into three bands, high, middle, and low. And the way that we're going to fly will depend on what part of the band we're in. Now, just to make it easier, let's assume for a particular day we've got 6,000 foot cloud bases. And we've ruled out the first 1,500 feet. So we've got 4,500 feet to divide into three bands. So that means the high band is going to be 4,500 feet to 6,000. The middle band will be 3,000 to 4,500, and the low band will be 1,500 to 3,000. And we're going to fly differently depending on where we are. When we're up high, in the top of our height band, we're going to be selective. We're only going to use the better thermals. And here is where we're going to fly a little bit faster and follow most of our modified speed to fly that we'll talk about in a little bit. As we get lower and down in the low band, we shift literally into survival mode. We slow the glider down so that we get closer to max L over D, and we can cover more area with the altitude we have in a search for lift. In the low band, which again in my example is 1,500 to 3,000, we're pretty much going to use any lift that we find. And in the middle band, we're going to stay alert. We're going to fly with discipline at a moderate speed and try our best to get back to the high band and back into being connected with the clouds. Almost all experienced cross-country pilots fly this way. We fly differently depending on where we are in the height band that we're using, and also modify a little bit based on what we see coming up ahead, if we see a blue area, if we see overcast areas, or that sort of thing. So it's important to recognize when we talk about speeds to fly, and we'll touch on them very briefly, we're going to fly differently depending on where we are at altitude. Now, some basic strategies about cruising at this point in your career. There are three rules: get high, stay high, and don't get low. I credit those three rules to Rick Shep, who was one of the people that helped me almost 50 years ago in terms of beginning to learn to fly gliders. But particularly at this point, it's real important for you to stay at the top of that height band. You want to try and stay in that top 1/3 of the height band, but just a little bit below the cloud base so you can see the clouds ahead. If you remember your experience flying locally, you'll know that sometimes as you're getting close to the cloud base, particularly if it's a domed type cloud base, you can't see the other clouds around you. And you want to try and understand the pathway and the connections of the clouds. Generally, we're going to talk a lot about going upwind versus downwind. Another part of your strategy is don't use a weakening thermal unless the combination of weakening thermal and down in the wind flow is going to get you where you want to go. Try to understand a little bit about wind speed changes with altitude. The higher you are, the stronger the wind. The lower you are, the less wind. Lastly, know the exit direction of the thermal before you get to the top. We've all had this experience where you forget to do this, and then once you get to the top, you get confused about what direction you want to leave in. And it's much better, particularly as you get, within 1,000 feet of the cloud base, to look out at the next cloud, the direction you want to go in. Pick a point on the ground, because remember, you can always see the ground even as you're getting closer to the cloud, and head towards that. So you need to know the way out. We're not going to talk a lot about thermaling here. We're going to do that more in the advanced program. A little bit more ideas on cruising at altitude. you want to try and stay connected to the clouds, and divert is needed to do it. My friend Phil Jeffries, who's a great British pilot, he uses the phrase, fly in the shade. So if you see clouds spread out ahead of you, and we'll talk about this a little bit more in a minute, you want to divert your path so that you can connect with as many of those clouds ahead of you as possible. And the reason for that is obvious. Even if there's a small amount of lift, that small amount of lift under those clouds greatly increases the L over D of your glider. The second issue that beginners often have difficulty with is they leave a thermal, and then 2 miles later they jump into another thermal, and which is kind of crazy because they, like at this point, 600 feet below the cloud base, but they're trying too much to thermal and too frequently. Let yourself go. I picked 5 to 7 miles because it's 10 kilometers, and that's generally a pretty good rule of thumb. One of the reasons I like the metric system is it's easy for me to think in terms of, 30 to 1 in the metric system means that I can go 10 kilometers and lose 1,000 feet. So you want to try and fly 5 to 7 miles or about 10 kilometers before you reach your next climb. Deal with physiological issues when you're up high, and that means eating, and it means urinating and eliminating. Do it when you are up there. It's much more difficult to be scratching around low at 1,800 feet or 1,500 feet or 2,000 feet if you have to urinate at the same time, or you're beginning to get hungry. So when you get to the top of the thermal, do a check on yourself. How am I doing? Do I need to relieve myself? Is this a time to have a bite to eat? You don't want to be dealing with any of that down close to the ground. Speed to fly. One of the reasons I assigned everybody the Bruce Taylor article was because he really deals with the whole issue of speed to fly as succinctly as you need to at this point. And at this point in your career, basically you don't need to worry about classic speed to fly. Number one, nobody flies classic speed to fly. It winds up making you fly too fast. It reduces your efficiency and your range to find new thermals, and it just makes everything happen much too fast. As Bruce Taylor says in the article, just pick your best L over D speed and add about 6 knots speed for every knot and a half that you are climbing. So if you're in a glider, that has let's say it's got a 50 knot L over D speed, and if we're climbing 2 knots, it'll be fine to cruise at 62, 63 knots. You don't need anything more than that. There are things in cross-country efficiency that are way more important than classic speed to fly. This is an idea that I stole from an American racing pilot named Pete Alexander, and that is to work on keeping your eyes outside of the cockpit at least 90% of the time. We get totally focused on our flight computers, our instruments, our altitude, and we completely miss the other glider that's out there circling, the birds that are out there circling, the trash bag that's going up in that giant thermal that's about, a half a mile away. Everything you need to know is outside of the cockpit. And 90% of the time, remember, means 6 seconds of every minute is spent looking at the instrument panel, and the rest of that minute is spent looking outside. And particularly when you get low, that's when it's most important to see the birds, see the other gliders, see the trash bag. So stop focusing on your instrument panel and start focusing on everything that's happening around you. This next thing is really the introduction into a section about cruising. This is a picture of a stubble fire that became a thermal. And I love it because it is, let me see if I can turn on the high laser pointer here. I love it because it really demonstrates the issue of how narrow the thermal is at the bottom and how wide it is at the top. You can see the diameter of it is increasing about six-fold up here. And this is pretty classic thermal development. In the advanced course, we're going to spend a lot of time talking about the fact that this is surrounded by sink. But right now, what I just want you to focus on is that the difference between right here, which is probably 1,500 feet, and right here, which is, very close to cloud base, is geometrically about 6 times bigger. Well, so why is that important? These are cone-shaped things that Rick helped me develop years ago that reflect the cone shape of this thermal. And, 6 times bigger at the top than they are at the lower level. This blue plane is, we're going to look at differently in a second, is slicing through the cloud base area, the top of the thermal. The red pane is slicing through the low area. Now, this is what the red area looks like as we look down at it. If this is being clear, that we're looking at this plate, and we're seeing that the field of thermals is so much smaller. But now, when we go to the 6,000 foot cloud base level, we see everything is so much bigger. So now imagine we're flying cross country, and this is one of the reasons, maybe the biggest reason, why it is so important to stay high. The footprint of the thermals is so much larger. So let's suppose we're going like here. We really can't find a pathway that gets us effectively through this. We might do this or we might do that. But when we go at cloud base, it's so much easier to pick a pathway that keeps us connected to the clouds and flying in the shade. We can go down like this, we can go here, we can do this and pass through it. This is fundamental to effective cross-country flying, because while you're in this area, even if it's not worth thermaling, if you're going through 50 foot per minute lift here, you've turned a 30-to-1 glider into a 45-to-1 glider. If this is 100 foot per minute and you're in a 31 to 1 L/D glider, you're basically not going down at all. So this is why it's so fundamental to get and stay as high as you can and try to stay connected to the clouds. Everything happens a whole lot easier. The last thing I want to talk about before I turn it back to Rick are strategies to take when you get low. And this is when we're getting down into the bottom 1/3 of our height band. And rule number 1, in the bottom of the height band, work any lift, no matter how weak. There's a time and place, if you're in a national championship and you might win it, that you're going to pass through a weak thermal at 1,500 feet. But you and I are a long ways away from doing it. In the bottom of your height band, you work any lift, no matter how weak it is. Below your safety altitude, never leave zero sync. Zero sync, if you're circling and you're not going up or not going down, what zero sync is a 50 foot per minute thermal that you're not working right. And if you really focus on absolute efficiency in that zero sync, you will climb. If you don't climb, at least you've got time to look around, see if there are birds, see if there are other gliders, see if there's something going on. Zero sync at least gives you time. And most of the time, zero sync is one of two things. It's either the beginning of a thermal, in which case, great, hang on, because you're going to start to climb it a little bit. Or it's the end of a thermal, in which case you're going to have a little extra time. Use your available altitude to cover maximum ground and do not cover the same ground twice. In the next screen we go to, we're going to spend a lot of time talking about that. But in South Africa, I do some coaching, and frequently I'm asked to coach the pilots who have trouble because they land out a lot. And when I see, I usually the first thing I do is I'll look at their flight traces, and their final phase of their flight trace, kind of looks like a bow tie. They go out, they come back, they go out, they come back to their field, they go out, come back to their field, and it's really not very effective. What you want to do is to use that available altitude that you have to get yourself upwind, and then make an organized search of the area to look for lift. And we'll talk about this in some detail. So the second component of this is you've got to get upwind of your landing site if at all possible. Why? Because a weak thermal will let you drift back towards your landing site. Whereas if you start going downwind in a weak thermal, you're going to have to use all of your altitude to get back to your landing site if it doesn't work out. So you design a flight path to take you over lift sources or ground protrusions that get yourself to your landing field ready for the powder. As you get lower, be prepared to use more bank than you use when higher. Remember the picture of the thermal that we just saw. It's going to be narrow down low. And lastly, of course, know when to give it up. Know when to not, stop looking, and it's time to get the machine on the ground, whether it's an airport that's below you or whether it's a field that's below you. Let me see, I want to change this and go to the next screen. This is hopefully going to be an illustration of all of what we just talked about in terms of low save strategies. You're looking at Turner's Falls, and this is the runway here. And in this particular model, this was actually patterned after a couple of different saves that I did at Turner's Falls. Our wind direction is coming from the northwest, as it normally would. And I want you to work with me and assume that where we are here is that we're coming in, we're heading towards Northampton, and we're right about here, and we are at 2,000 feet MSL, which is about 1750 above this airport. Now, going back to the idea that I talked about, what I would normally see with a brand new cross-country pilot is something like this. I'll go over here, and then I'll come back here. I don't want to get too far away, so this. And what it looks like is a giant bow tie. And eventually they fail, and they start their pattern, and they're going to land on the runway. Now, one of the reasons that's absolutely useless is because let's look around. Our wind is coming here in this direction, and we're right here. What's immediately below us? A whole bunch of trees. What's immediately upwind of us? A huge part of the river curve area that is just going to be cold and do nothing to develop any kind of a thermal. This is a bad place to be in. But let's look around and see what we've got. Okay, remember, upwind is here, though our wind is coming this direction, all right? So let's look around. We've got 1,800 feet to spend. Well, what do we got? Well, there's a factory right there. Big black roof. That's its thermal source. This is a solar farm. Well, that's pretty good. This is a huge, oily, black railroad yard. That's interesting thermal source. There's a rock quarry. Here's a big area of infrastructure over here. Here's another smaller area of infrastructure over here. So this is what we're looking at as we're getting low. We're thinking about the wind. We know where our field is. And remember, if we get out here and we get into, let me get rid of this for a second. If we find a thermal out here, you know, we're going to drift towards goodness. We want to drift, even if it's a weak thermal, it's going to take us right back to where we want. So what I'm suggesting should be done here is pilot comes down, and I'm going to just change writing utensils here because it's easier. So as the pilot comes down, they turn this way into the wind, down over this area, over the rock quarry. Do it again. Now, at any time, if we're getting low, remember, we can bring this back, but we come back up over the infrastructure area, back down here. And if none of this works, we're now 1,000 feet, and now we can go in and land. This technique of heading upwind and using the available sources that are likely to give off thermals, using the tools that you have, is one of the single most important things that we can teach you in this course. This is the difference between landing out and not landing out. The pilot who does this has a 9 out of 10 chance, if the day is still working, of finding lift in this area, in one of these areas. And if you don't, you have the satisfaction of knowing, even if you do land, well, okay, I gave it my best shot. I used every tool in the toolbox, and now I'm on the ground, and there's nothing more I could have done. And conversely, the pilot who stays here and just does, you know, the fooling around there has got no more than a you know, a 1 out of 10 chance of maybe of getting the thermal that's going to take them away. So rule number 1, get upwind. Rule number 2, use your altitude to get over what the most likely thermal sources will be. Number 3, adjust as you're using altitude so that you always come back to a place where you can start a good pattern. But this will save your bacon. It saved me a bunch of times from being low at Furnace Falls, and it got me off. So that's the end of my segment now, Rick. I think it goes back to you. Am I right?
Yep.
Stand by.
I just got to make a comment here because you'll note that all of the things that Roy pointed to were on the ground. There's another handy rule of thumb. If you're in the upper half of the atmosphere, look up, and if you're in the lower half, look down. If you try to chase clouds, you know, low, it's a very iffy thing. One, you saw that the thermals are cone-shaped, so they're going to be a lot smaller. And secondly, they're just so far away from the sources are so far away from the cloud that you really need to change your focus. So,
all right. Rick, do I make you host again?
I don't think you need to. I don't think you were host. So let me see.
All right.
All right, we switched.
Yeah.
All right, so I'm going to talk a bit about glide computers. You know, they used to be esoteric, expensive things, and now most of you are walking around with one. There's free software that is available for your phones, and there's a bunch of other options, but they are wonderful devices. You don't need one. You can do it without, but in the old days, people would fly with like a circular slide rule that was affectionately called a prayer wheel, to try to figure out your L over D and effects of wind. And, you know, just like we don't use maps anymore because Google Earth will, or Google Maps will do it for us. I'm a huge fan of glide computers. They don't guarantee anything, but they make these calculations so simple that it's a great thing to just be able to refer to them for pertinent information. So what is that pertinent information? Arrival height. Arrival height is really mostly what I use it for. You know, I've got, if you're back to that drawing when we were going from, say, Sterling to Gardner, I'll try to have an easy way to switch between the two so that I can always know how high I'm going to be when I come back to Sterling, or if I go ahead and press on to Gardner. And it's the one, that halfway point we talked about is when the arrival height at the two airports are the same. So now you're in the, you know, you've got a choice: go forward, be able to advance forward, or fall back if you have to. Now I'm going to say a controversial thing where Roy and I have a disagreement, but I think if you're going to use a glide computer, it makes lots of sense to remove the safety reserve, so that when I look at the arrival height at an airport, I'm seeing how high I'm going to be AGL when I get there. There's lots of flight computers, all of them, that you can put in a safety margin so that when it says 0, you're really going to arrive at your safety height, with the idea being that that will help you do that somehow. But the experience that I had, most of you know that I ended up in a lake. One, at the time that I was needing to make a really important decision, should I press on or should I find an alternate landing area, I was slightly under my arrival height, and it required a lot of mental math that I was all bunched up as it was. So simply by having it be the actual arrival height has been a wonderful change for me. So that's the end of that. Maybe I think I may have another slide about it.
Equal. Can I get equal time for that?
Yeah, go ahead.
This is one of the things that Rick and I do disagree on, and that is every flight computer has a safety reserve altitude so that it sets up your glide not to hit the dirt at your destination field, but rather at an adjustable height above. Rick and some other people characterize that as the same thing as setting your watch ahead so that you're not late for a meeting. And I say, what's wrong with setting your watch ahead so that you're not late for a meeting if being late means that you land in a pond? I find I still fly with a reserve altitude of 1,000 feet locally around here. When I'm in contests, I usually trim it back to about 750 feet. And I'm always cognizant of what that reserve altitude is, so that, you know, if I'm coming back to Sterling and the computer says I'm at minus 200 feet, well, okay, I can live with that because, you know, that means I'm going to arrive at 800 feet and I can slow down a little bit. I find it's helpful, and it helps me think the way I want to which is to think in terms of arriving at a reasonable pattern height as opposed to simply arriving. But what you have now in front of you is two experienced cross-country pilots who simply disagree on a point, and there'll be other ones like that too.
I'll give you another shot when we get to the next slide.
Okay.
So the other thing, this nearest airports, and on some glide computers, when you look at a list of nearest airports, it'll give you the arrival height to those airports. So you can actually just have that screen up when you're making this kind of transition between airports and be able to watch both arrival heights from that screen. But obviously it's a super nice thing to be able to, geez, what are my options here to pull up a page of all of your closest airports. The wind is very important. Roy talked about flying into the wind for this search. Lift tends to organize along the wind line. So if you get into lift, if you're able to fly directly upwind, you're liable to stay in it a little longer. It's something you'll hear the pilots talk about on the air. Hey, what do you have for wind? It's a very useful piece of information. Most of the simple flight computers or GPS only flight computers, so your phone or say a Kobo with just a GPS input, only get wind information from thermaling. So as you circle, it calculates your drift, and that's how it gets the wind. So in wave situations, it's not as helpful, but more sophisticated ones will also calculate the wind in wave. And actually, I bought a new instrument a couple of years ago that does instantaneous wind calculation, which is really, really cool. Literally, it updates every second, and it's quite interesting to see the wind field around a thermal. You'll be flying in a 20 knot wind, get in the core of a thermal, and the wind will be significantly less because of the inertia of the wind trying to move this massive amount of air. It actually gets slower. Navigating to a waypoint, or for that matter, navigating home is the obvious thing. That's the, being the Google Maps of the air. And this Roy added, and I spent a lot of time looking at it today just because I don't tend to use this that much, but what could be better than giving you your altitude above the ground, even at a foreign location or field? Now, they're not super accurate, but it's better than nothing for sure. And so these flight computers, which have maps with terrain databases in them, can figure out where you are and subtract out the elevation below you and tell you what your AGL is. Generally in New England, I don't use this that much, but out west where there's big terrain changes and big plateaus, Roy and I were talking about this, there are certainly places in New England where you'll run into this where, geez, I'm at 5,000 feet. How come it looks like I'm close to the ground? And so this is a very useful tool. And the rest is racing fluff. If you ever looked at like the manual of an LX 9000, it's crazy how much stuff is in there. But really, these things above this line is what you are interested in. There's all kinds of stuff to help you get back on time and a turn area task and yada, yada, yada. It's these things somewhat in this order is what I find useful to a new cross-country pilot. So arrival height, people tend to, if you keep a sort of reserve L/D, so you're in a 30-to-1 ship and you figure, well, I'm going to have, if I'm 20-to-1 to something, I'm in good shape, versus holding an arrival height, whether this is your built-in reserve or the reserve you're looking at, which says I'm going to get here at 2,000 feet. you're going along and trying to maintain that. This is not a steady glide, but basically you're thermaling as you need to stay above this, versus thinking that your reserve glide angle is going to help you, because as you get close to the target, you're going to be much lower holding that reserve glide than you would if you were trying to hold an arrival height. So I think it's a better thing to do, and again, it's easy to do with a flight computer. Yeah, here you go. So 21 1 mile out is 262 feet. Not a place I want to be, and you can't really hold a reserve L over D to a place up in the air. Longer glides are more likely to work out. This is a counterintuitive thing, but the farther out you are on a long glide, the more likely you're going to run across some lift. And even if you're just what they call dolphin flying, slowing down in that lift and speeding up in sync, you're more likely to have things work out. But if you're a mile out and you get crushed in sync, you don't have time to find the lift that's on the other side. So generally, you can kind of trust these glides a little better as you're farther out. So arrival heights. I stuttered here because this really should be 1,000 feet. Oh, I know what I was trying to say here. Sorry. I hold, when I'm coming back, I'm very conservative when it comes to, coming back home. I want to make sure I really get there. I generally hold 1,000 feet over your pattern height. If things go wrong, something doesn't quite work out, you've got plenty of margin and still get there at pattern height. The arrival heights are AGL, they're not MSL, so they're really kind of what you want to know. And here's back to my don't use a software reserve. Here's my argument again. When you really need to know, you've fallen below your glide. Roy gave you that example. I'm 200 feet under glide. Well, that means I'm really 800 feet. But wouldn't you rather look and see 800 feet? Here's the example. You're 352 feet under glide with your 1,000-foot reserve. How high are you? So that's the answer, but you had to go do mental math to get it. Whereas if you have this zero reserve, you're seeing the exact number. And that's, I caught myself, and I think every cross-country pilot that I know coming back home has said, I'm 1,000 feet over 1,000-foot reserve. This makes more sense to me to say, I'm going to arrive at 2,000 feet. So anyway, that's the end of my argument. You want to pitch in or leave it?
Well, we can leave that one.
Yeah, okay. Now, the really important thing about this is that while I fly with no reserve, software reserve in my computer, I certainly don't do a glide at zero reserve. For a fact it's not going to work. And so it doesn't have anything to do with the margins that I would hold. It just has to do with the mental math that I would do to hold those margins. Yeah, and this, go ahead.
We talk about final glides pretty extensively in the advanced program. I think for the people in this program here, it's just, give yourself a healthy reserve, as you're on final glide to your destination field.
Yeah, no, that is the important thing. And I think I've got a slide on final glides that has nothing to do with reserves. So I would say that in your flight computer, I do like a reserve for the map display. And it's not always possible to do. ClearNav actually has, when they show what I call the landing shadow, they call it an amoeba. It shows where from the height you are, how far can you get? And there's actually two bands, one that is where you're going to hit the ground, and the other is where you're going to be at some margin that you've set. And that's what I like to do. I like to say 1,000-foot reserve for what you're going to show me on the map, so that if I see an airport that I want to go to, I can visually identify right there, okay, I'll be able to get there at pattern altitude. That's different than when I look and, I'm updating information on that glide. How high am I going to be when I get there?
Yeah. The LX 9000 has a setting that will do that too also.
Does it? I couldn't find it. It has a safety McCready, but
No, as you pointed out, that it's very complex and you need to know where it is, but it will do one of two things. It will actually draw the same line and shade in the area that you can glide to. It's a setting called, I think, called Show Glide Area. In addition, it will also light up green the airports you can glide to at your current MC setting, and an orange at a 0 MC setting.
okay.
But it's just trying to figure out how to do it.
Exactly. So here's a little thing, final glides in quotes, because it sounds so sort of like dead reckoning, it's not a friendly term, but it's really just about getting home.
Yeah.
So to practice this as new pilots, new cross-country pilots, and get confidence in it, work your way away from home until you've got your home airport or 2,000 or 3,000 feet above glide, and come back and see how it works. Because one of the things is, you're going to pull a polar, probably, a canned polar for the B4, may or may not be representative of what our B4 is all about. And so you want to see if over a long glide, it is being true to you. And that, of course, will vary depending on the kind of air you're in. But if you're in, sort of equally distributed lift and sink, then see how it works out. And again, you've got to glide for a pretty long distance. Final glides are generally not interrupted by thermaling. You've hit your final glide and you're going to glide all the way home, unless you've run into a bunch of sink that's unexpected that you would actually stop for a thermal. You will slow down in lift and speed up in sink, but generally it's one big long glide. And I've actually had 2 times that I've had a final glide of 100 miles. And it's a strange thing, but it can happen if you get high in the right place. So you need to gain confidence. Longer glides are more likely to work out, as we said. Downwind glides are scary flat, and it's something you want to watch out for. When you are coming back home downwind, it says no problem, you're going to get there at 1,000 feet. But if you, and Roy pointed this out at a thing, if you're coming back to Sterling in a strong downwind thing, your 30-ish to 1 or 40-ish to 1 glider is now 60 to 1. And that terrain is slowly descending, and you're going to find yourself much closer to the trees than you want to be. So keep that in mind. So here you go. A 134 with a 25-mile-an-hour tailwind is flying like an open class glider. Watch out for declining tailwind with altitude, because that's the other thing that happens. You've got 50 to 1 when you're, at 5,000 feet and you've got the strong tailwind. It says you've got the glide made, but you know that as you descend, you're going to lose some of that tailwind and your performance is going to decrease. So that's something else you need to keep in mind. You need more margin on a downwind glide because of the fact that your wind gradient is going to work against you. It actually works for you in an upwind glide. As you get lower, you're generally going into less wind, but particularly watch out for a downwind. So the SN10, it's free in RB4. It has a club mode that's generally a little simpler. Read the manual and get used to it on the ground. You can sit in the glider and fiddle with it, or there's a simulator available online where you can run it. It's not the friendliest machine, but that's, you know, in deference to Dave, he didn't have a lot of pixels to work with. So he tried to get the maximum amount of information on these screens, and they sometimes are confusing. I have one in our duo. A lot of people in our club have flown with them. They're very good instruments. The Vario is good. As a matter of fact, the B4 Vario, I think, is one of the best ones in the club. But it needs practice. But we got plenty of time to sit around online and get to know it well. Or if you've got your own, go ahead and do that. So here's a little brief thing. XC Soar is a program that was originally developed in WinCE. It has spun off at least 2 other open source software. One is Top Hat, which is very popular. Top Hat will also run on a Nook or a Kobo. Those are e-readers, so they are incredibly good in bright sunlight. The brighter the sunlight, the better you can see them, versus your phone, which may have difficulty in bright sunlight. So I fly in the Duo with 2 Nooks, I'm sorry, 2 Kobos. I actually have printed new case backs for them so that you could put a GPS built into it. So this thing, you know, it's maybe a 5-inch square or 4x6 or something, fits in your pocket, runs all day on its own internal battery. It turns out to be a great device, and I'm happy to provide backs for anybody who wants to try to do that project. Yeah, I think it's worked out really well, and is easy. Then Roy uses Audi, and why don't you talk about it, Roy?
The Audi works pretty well. I actually haven't used it too much in recent times, but it basically is a compact, portable flight data computer with the ability to set tasks, the ability to input elevation, and once you get to know it, it works really well. And what's nice about it is it's completely portable.
Yeah.
It has some limited battery stuff, but okay.
Yeah, the new one, the IGC one, which has a built-in logger, I think has much longer battery life. But
well,
obviously,
what you could, yeah, well, the trick is you can buy one of those battery charge packs and connect it and run the
yeah,
thing all day on it. Do you want to try and do the Danielson stuff? We've gone. We could probably do it quickly.
sure.
Okay. Are you?
Yeah.
Are you?
I'm good here. That's it for me.
All right. Stand by while
hang on.
I'm still host, right?
No, I've been host all along, but all you have to do is share.
Okay, stand by. And
What were we shooting for, Roy? Was it 2 hours or
I thought we
less?
were shooting for an hour and a half, but can you see my screen now?
Not yet.
All right, hang on. I think this only works if I'm the host.
No, you did it last time.
All right, how's that? What are you seeing now?
You. But I could throw you the host back if you want.
Yeah, why don't you do that, okay?
Last time I said that and you figured it out before I did. Let's see. Make host. Okay, you are now the host.
All right, and can you see my screen now?
Yes, we can.
All right, hang on. Hang on. All right, let's go quickly through the 1% rule. You seeing that screen, Rick? Rick, have I got audio? Hello? Did you, are you hearing me or not? Okay, good. All right, good. All right, let me see if I can, Rick, talk to me for a second. Can I unmute you?
Can you hear me now?
Yeah, I can. I have no idea what just happened.
Yeah, something happened when I gave you the host. I muted myself, and then it said the host muted me, and I couldn't unmute myself. So
All right, let's
we're good.
try. Let's try again now. Are you seeing my screen?
I'm seeing Roxy.
That's good. All right, now you're seeing the 1% rule to Danielson.
Yep.
Okay. Let's just talk briefly about the 1% rule, and I'm going to speed things up a little bit so that we can do this. The 1% rule essentially means that your effective L over D needs to be 100 to 1. The purpose of the rule is to prevent you from taking a super high tow and then doing your silver distance, which wouldn't be a whole lot of fun and wouldn't be fair. So what we have to do is calculate the start elevation, the end elevation. We have a loss of 239 feet. Our distance from Sterling to Danielson, 68 kilometers. So when we do the math and subtract the 239, our maximum tow for this flight is going to be 1,995. And so that's our maximum tow height. This is a picture of a sectional, and if you can see this, the next screen should show the course that we're going to go through. And Rick, help me again. Do you see a blue line there?
I do.
Again, please, Rick.
Yes.
Okay, good. All right. So what we're going to see is we start at Sterling. We're going to go down. We're going to look at this is Spencer here, but we're going to look at a farm field that's about midpoint here. And from Spencer, we're going to look at some more farm fields on the way to Southbridge. Southbridge, we've got two airports. We've got an airport that's called Toutant, which is right here. It's a small field, but it's certainly landable, owned by a helicopter pilot named Ernie Toutant. This is Woodstock, and then this is Danielson here. So let's try and go through this quickly. And this again is a Google Earth. Looks like what it is what it's going to look like. And let's start going through and see what we got. Okay, so we started Sterling. And our first waypoint here, this is Mason Farm. This is the farm that you've all seen. It's up on the hill to the west of Worcester. We're going to look at it in a whole lot more detail in the next section as we talk about ways to approach this field and ways to land in it. But for now, just take a look at it. It's your first waypoint. It is about 6 or 7 kilometers to the west of Sterling. This is your next waypoint, and this is Alta Vista Farm. It is in Rutland, almost exactly on the Rutland-Holden border. It is a great off-field landing site. This is a farm called Lilac Hedge Farm, but this is a 2,000-foot really nice field, and this is what a different view of it here. It's just immediately north of what's called the Pine Hill Reservoir. And I'm being real quick. We're going to do this in much more detail the next session. But this is what Alta Vista Farm looks like on the ground. Guys, it doesn't get any better than that. Guys and gals, it doesn't get any better than that. This is a field that I walked just a few days ago, and it still is pretty good. A lot of the films that you're going to see later on were taken years ago. This is Spencer, which is the next trip. So on our way to Danielson, followed by some farms that are between here, Spencer and Southbridge. These are big fields that anyone should be comfortable landing in. There's another one here. We're going to talk about size of off-field landing fields, but these are all pretty good. This is Southbridge, and about halfway on the way to Danielson. Somebody asked a question at the beginning, why are we going south? Why don't we go north? The answer is, number one, we want to go downwind. Number two, we generally want to go downhill. It is not easy to go upwind out of Sterling. You're heading to Gardner, which is 500 feet higher. You get up on the plateau, and there's very little but trees between Gardner and Keene or Gardner and Jaffrey. This is much, much friendlier territory, and that's why I like to send the new cross-country people down. This is Woodstock. It's very distinctive because notice the runway is in two different colors. I don't have a picture of Toutant, but Toutant is distinctive because it's a runway similar to this, but all it has in it is a single building that houses Mr. Toutant's helicopter. But it's a good field also. This is a landmark which is about 7 or 8 kilometers north of Danielson along the river. I believe these are power plants, but it's very distinctive. You can see it from pretty far away. And this is the approach into Danielson from pretty much over those power plants. And finally, your arrival here is at Danielson. There's a glider club at Danielson. They have tow planes there. They're really nice people. And it's a great place to fly. So that's the first tour. On the second session of this, we'll be doing a tour which will be Sterling around the east side of Worcester down to Taunton, again downwind and downhill. And we're also going to spend a lot of time looking at pictures like this, photos of farm fields from the air, and then looking at what they look like at the same time on the ground. Couple quick things before I stop talking, turn it back to Rick. We started at the beginning with people noticing that Fitchburg Airport is closed. Fitchburg Airport is now NOTAM closed, and it did have one runway open for a while, but there's a runway extension program in effect there, so they've got heavy equipment, and that's not available field, and probably will not be for the next 5 to 6 weeks. Similarly, Marlborough Airport no longer exists. It was bought for real estate development. It's got heavy equipment all over it. You should take that off too. So I'm going to stop there, Rick, and turn things back to you.
Yeah, do we want to stop and go for questions, or do we want to just...
Yeah, let's stop here and go for questions.
Sure.
We got a bunch of them, so...
Do you want to try, we'll see if it's manageable to unmute people and let them go ahead and ask questions?
All right, but let's make some rules, okay? And that is that only one person asks a question at the time, and we're going to try and unmute everybody. All right. And because a lot of people don't have video, please identify who you are. And also, I just unmuted people, but some of them have mute on their own screens. Okay?
Any questions?
I don't hear any.
Not sure it's working.
Yeah, I'm not sure it's working either.
Testing audio.
Yeah, there we go. We heard you.
So Roy, that run through of the Danielson path went pretty fast.
Yeah, it did. It was designed to because we're running over time. We've actually got a lot more material to cover here.
Wait.
Hello? Rick, talk to me.
Yeah, I can hear you.
Yeah, I think this is not working. So what I'm going to plan to do is just go through some of the chat questions, okay?
Okay. Yeah.
First of all, somebody did point out that Danielson does have a very active jump club. It does. That's true. It has the advantage, however, that the jump zone is pretty much north of the airfield. They don't parachute onto the runway, although their tow planes do. But you do have to pay attention to the fact that there is a jump zone to the north of that. Yeah, somebody indicated there's an echo problem when we unmute everyone, and I think that probably happens because a couple of people are using telephones, and when you using telephone and computer at the same time, you get a feedback loop.
Yeah, well, we're happy to take the questions from the chat. And yeah, I see a question about the 1% rule. The 1% rule is a rule for where you release to what constitutes completing the task. And I will talk about the actual task with a secure logger. And I think for the most part, you probably won't need to worry about the 1% rule because with a logger, your finish can be in the air, and you know, in many cases, you may finish higher than you started.
Yeah. I want to go back to an earlier point, and that is why it is that, you know, for new cross-country pilots, I recommend that people go south instead of north. And the short answer is it's infinitely friendlier and infinitely easier to go south from Sterling than it is north. As you go north from, and particularly upwind northwest, you are going into the wind and uphill and over a very large forest. And so it's just we're at, you've got everything working against you. And I think like a 120, I'm trying to think like a 126 pilot here, and trying to get, for example, to Keene or to Jaffrey in a 126 is going to be very difficult unless you've got a really high day. But getting to Danielson or Taunton in a 126 is not difficult. You're going downhill, you're going downwind. And you've got airports, and you'll see, particularly with respect to Taunton, you've got a lot of airports except for the very first section. And I understand that a few people have gone west out to Turner's Falls on that area. And if you're going to do something, that's probably the best way to do it. But the stretch from Gardner to Orange is essentially unlandable. The segment from Orange to Turner's Falls is definitely unlandable. And I don't want to send new cross-country people over places that are uphill into the wind and unlandable.
Yeah. So
it-
I do have a task that in a later presentation that talks about going west, is what I did for my silver.
yeah.
It's reasonable, but Roy is right. It's a lot friendlier going south. If you're going to go do an out and return, which is probably what you want to try, there is a quite reasonable path out there. Going northwest, going to Jaffrey is not for beginners. That's a whole long stretch of unlandable terrain, and but going and without Fitchburg, it changes things a lot, because Fitchburg,
Yeah.
particularly going northwest, was really your fallback. And there are some good fields out there, but there's not a lot of them. But there are long stretches going to Jaffrey that are sketchy.
Yeah, with Fitchburg gone, it's going to be important to find out what the status is of Mason. And the only way to do that is I'll try and fly up there in the Santabria. But
Is that what they call the dirt strip? Where that
well, it's
DC?
grass. Mason is in Mason, New Hampshire. It is southeast of Jaffrey on the other side of that spine of mountains, that runs up to the east of Jaffrey.
On the west side of the high ground.
Jaffrey's on the west of that spine and Mason's on the east.
Oh yeah. Yep.
So I think it's important to do that. Again, I want to emphasize to people, this program is about encouraging people to make their first cross countries. And if I feel pretty strongly that going north or west out of Worcester, out of Sterling, is not the place to go on your first cross country. It's uphill into the wind in all trees. All right, any other questions anyone wants to text? Talking just doesn't seem to work well.
Yeah.
All right, let's talk a little bit about the next session if we can. The next session, you're going to see a similar guided tour that hopefully I'm going to go through a lot slower, and that's going to be Sterling going down to Taunton. And then we're going to have a presentation on landing field selection off airport landings and landing in schoolyards, landing over roads, what's dangerous, what works, what doesn't work, how to pick a good field and how to approach it. And you're going to see a lot of photographs taken from the air and the ground at the same time. I want to emphasize before we get into that, the next session, that some of those photographs were taken 10 years ago. And they're helpful to show you what the field looked like from the air and the ground at that time, but they shouldn't be relied on now for the condition of the field. Sometimes we do go out and still look at fields. I just went and looked at Alta Vista Farm a couple of days ago because it's just an important place for me to know that it's landable. Rick, what do you have for the next session?
We will have what the actual procedures of doing the silver badge with a secure logger, and some weather, and I think that might be it for me. I was going to say, while we're stuck on the ground, it's something that I'm not sure beginning cross-country pilots realize that we do, but we do drive to look at these fields. Up in Gorham in particular, when we started to fly cross-country, that's an awful lot of bear country up there. And we would, a rainy day, we would all pile into a car and drive miles and miles to look at potential fields that were often found on Google Earth. And So, you know, if you're sort of thinking, well, this might be the path I want to take, you can look on Google Earth, you see some good fields, give you an opportunity to drive down and take a look at them on the ground, is a really worthwhile exercise. And reporting back as to what you found is also a very helpful thing. It's obviously nothing's guaranteed, but you'll see when you look at Roy's presentation. I went to a presentation given by Kai Gersten once, and we were at Mifflin, and people often drive down from State College, and he said, all you people came down from State College, how many power lines did you cross under? And it turned out to be like 430, and nobody had any clue. You really can't see power lines from the air. And so going out and looking at a field up close is a really helpful thing to find out, you know, are there lines to worry about? If so, where are they? So
Yeah.
looking to pass some time, it might be a good thing to do.
Okay, and I'm looking at a chat message that somebody sent, and I'll read it. It says, always thought of going upwind for the tax so it's easier to get home. Wrong think, question mark. The answer is it depends on your experience level. If you're an experienced cross-country pilot, it makes great sense to start upwind and go as far upwind as you can so that as the day gets softer, you know, you can drift your way back home and weak thermals take you back home, and that's a perfectly good strategy. But it is not a strategy for beginning cross-country students who need to have a safe, relaxed, and fun flight. I have flown upwind into Keene out of Sterling, and it's all hard. You first thing you're doing is you're going uphill 550 feet from Sterling to Gardner, as you're starting to get up on the plateau. And once you get to Gardner, there is no place to land until you get to Keene. And it's nothing but trees and a few little hills and that sort of thing. There is one tiny, tiny field that I think an expert pilot in a flap glider could probably get into without damage. But, you know, to send a new inexperienced person, you know, upwind, no, we're not going to do that. You know, go downwind. Look at the airports you've got going downwind. You've got Hopedale, you've got Old Norfolk, you've got Mansfield, you've got Taunton. And if you're feeling good, you go to Plymouth. But you can't, going upwind is a real handful, I think, for anybody except a very experienced pilot. Let's see.
Upwind going south, you don't want to. South winds are generally not all that favorable, so.
Yeah, upwind, if you're going upwind going south in Massachusetts, it's raining. It's, you know, if you have a southwest wind, you're going, Danielson will take you down there, but usually when we have southwest winds, they're not very good. You know, the lift is weak. The visibility is hazy, and
lower.
It is. So, I mean, most of the time, when you folks will see me flying cross country out of Sterling, you know, my turn points are usually going to be Mansfield or Taunton, and then Windham, Connecticut, and then come up north to Keene, and then come back downwind from Keene. So that to me is a good flight.
And I used to fly north almost all the time as an experienced pilot, you know, go up towards Claremont or Springfield or, you know, Sugarbush. But last few years, I've started flying south, and I like it a lot down there. It's often really good. I sort of thought you had to get up onto the high ground for things to get good, but that's not the case. There's been some very good flying to the south.
Okay, just one last announcement. I am probably going to give new sign-in information, new link, new password for the Thursday night session, just because I think I don't know how to continue this. I see a couple of people, and right now it flashes and it tells me that John is talking or Ulysses is talking, but we can't hear you, so the best thing to do is to send a chat if you have a question, or otherwise, I think it's now 10 minutes of 9, so we ought to call it a night.
Yeah, I think we could wrap it up. And if you have questions in between, feel free to email us.
Yep.
We'll either discuss it in the group when we reconvene or answer it on the spot.
And there's a lot more interesting stuff, a lot more photographs that are coming up for Thursday on the basic course, and then we'll start to talk about the advanced course on Thursday. So unless somebody feels strongly otherwise, I'm going to move this to end the meeting, okay?
Second the motion.
All right, and we will see you all on Thursday. Good night, everybody.
Good night.
Oh, Rick,